Hello everyone, myself Mohammad Akram. I'm currently studying Computer Science and Engineering in Sri Venkateswara College of Engineering and currently pursuing third year and sixth sem. So today I'm going to do a small presentation on some topics. These are first one, introduction to data mining and data warehousing. Second, multidimensional models. Third, difference between OLAP and OLTP. So now let's get started with the first topic, data warehousing. Data warehousing is a combination of data from multiple sources into one comprehensive and easy manipulated database. The primary aim of data warehousing is to provide business and analytical results from data mining, OLAP, score aggregating, and reporting. Data warehouse. A data warehouse provides architecture and tools for business executives to systematically organize, understand, and use their data to make strategical decisions. A data warehouse refers to a data repository that is maintained separately for an organization operational database. The data warehouse system allows for integration of a variety of application systems. Williams states a data warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management's decisions making and process. The need of data warehousing. Information is now considered as a key for all the works. Those who gather, analyze, understand, and act upon the information are the winners. Information has no limits. It is very hard to have collection of information from various sources. So we need to have data warehouse from where we can get all the informations. Data warehousing includes retrieving data, analyzing data, extracting data, loading data, transforming data, managing data. The second topic, the subtopic is data mining, the non-retrieval extraction of implicitly, previously unknown, and potentially useful information from large databases. Extremely large database sets useful knowledge that can be improved, processed, cannot be done manually. Where has it come from? Data mining. Data mining mainly consists of these types: database, visualization, applied statistics, parent recognition, parallel algorithms, high performance computers, machine learning. So basically data mining is efficient and effective way of storing and analyzing data which helps in easy retrieval of data for any requirements of the users. Database today are huge, more than 10 lakh entities, records, rows, from 10 to 10,000 fields, attributes, variables, gigabytes, terabytes. Database is growing at an unprecedented rate. The corporate world is a cutthroat world. Decision must be made rapidly. Decision must be made with maximum knowledge. How does data mining work? Extraction, transformation, and loading transaction data onto the data warehouse systems. Store and manage the data in the multidimensional database systems. Provide data access to business analysts and the information technology professionals. Analyze the data by applying application software. Present the data in user formats such as graph or table. Comparison between data mining and data warehousing. The common database. A common database is an operational transactional processing. Each operation is an indivisible transaction. Data warehouse. A data warehouse is based on analytical processing. Database. Generally, a database stores current and up-to-date data which is used for daily operations. Data warehouse. Data warehouse maintains historical data over time. Historical data is the data kept over years and can be used for trend analysis, make future predictions, and decision support. A database is generally application specific. For example, a database stores related data such as student details in a school. Data warehouse is integrated generally at the organization level by combining data from different databases. Example, a data warehouse integrates the data from one or more databases so that the analysis can be done to get results, such as the best performing schools in a city. Construction of database is not so expensive. Construction of data warehouse can be expensive. Second topic is multidimensional data model. for data management where the databases are developed according to the user preference in order to be used for specific type of retrievals. Multidimensional database (MDB) is mainly optimized for data warehouse and online analytical processing (OLAP) applications. Enable interactive analysis for large amount of database for decision making purpose. Rapidly process the data in the database so the answer can be generated quickly. Provide just-in-time information for effective decisions making in successful OLAP applications. UData is multidimensional cubes, which has been particularly well suited for data analysis. Enforce simplicity. Types of multidimensional models: data cube model, star schema model, snowflake schema model, fact concatenation schema model, global schema, also called as global schema. Now let's get started with data model. Data data is grouped or combined together in multidimensional matrix called data cubes. In two-dimensional, row and column or products. In three-dimensional, one region, product and facial quarters. Dimension and measures. Data cubes has been categorized to data called dimensions and measures. Measures represent some facts or numbers such as cost or unit of services. Dimension represents this respective category of data such as time or locations. The second part is star schema model. It is the simplest form of data warehousing schema. It consists of large central table containing the bulk data and set of small dimensional tables, one for each dimension. Each entity relationship diagram between dimension and the fact table resembles a star where one fact table is connected to multiple dimensional table. For example, of star schema. In this, the sales fact table is the main table and the subtables are the time, branch, items, and location. These all are other dimensionals. The unit sold, dollars sold, average sales are the measures. The third part is snowflake schema. It is default form star schema. It is the dimensional table organized into hierarchical by normalization. Then the snowflake schema is represented by centralized fact table which are connected to multi dimensions. Example of snowflake schema. It is similar as the star schema, which consists of main sales fact table and subtables such as time, branch, item, and locations. But the main difference is item and location, which also consists of subpaths such as suppliers in the city in the dimensions. The difference between OLAP and OLTP. This is the third topic. The OLTP, online transaction processing. It is characterized by large number of short online transactions such as insert, update, delete. The main emphasis of OLTP system is to put on very vast querying, processing, maintaining data integrity in multi-access environments, and an effectiveness measure the number of transactions per second. In OLTP database, there is detailed and the current data and the schema used to store transactions database in the entity model, usually 3NF. OLAP, online analytical processing. It is characterized by relatively low volume of transactions. Querying is often very complex and involved aggregations. For OLAP system, a response time is an effectiveness measure. OLAP applications are widely used by data mining techniques. In OLAP database, there is aggregated historical database stored in multidimensional schema. Usually, star schema is used. OLTP versus OLAP. OLTP, online transaction processing. OLAP, online analytical processing. OLTP consists many short transactions, queries, and updates. OLAP consists long transaction, complex queries. OLTP examples: update account balance, enroll in course, add book to shopping carts. Example for OLAP: report total sales for each department in each month. Identify top selling books. Count classes with fewer than 10 students. OLTP, queries touch small amount of data, one record or few records. In OLAP, queries touch large amount of data. In OLTP, updates are frequent. In OLAP, updates are infrequent. OLTP concurrency is the biggest performance concern. OLAP individual queries can require lots of resources. Why OLAP and OLTP don't mix? Different performance requirements. Transaction processing OLTP. Fast response time important, less than 1 second. Data must be up to date, consistent at all the time. Data analysis OLAP. Queries can consume lots of resources, can saturate CPUs and disk bandwidths. Operation on statistic snapshots of data usually okay. OLAP can crowd out OLTP transactions. Transactions are slow, unhappy users. For example, analysis query asks for sum of all the sales. Acquires lock on the sales table for consistency. New sales transactions is blocked. Why OLAP OLTP don't mix? Different data modeling requirements. Transaction processing OLTP. Normalized schema for consistency. Complex data models. Mini tables. Limited number of standardized queries and updates. Data analysis OLAP. Simplicity of data models is important. Allow semi-technical users to formulate ad hoc queries. Denormalized schemas are common. Fewer joins, improved query performance, fewer tables, schema is easier to understand. Why OLAP OLTP don't mix? 3. Analysis requires data for many sources. An OLTP system targets one specific process. For example, ordering from an online store. OLAP integrates data from different processes, combines sales, investors, and purchasing data, analyze experiments conducted by different labs. OLAP often makes use of historical data, identify long-term patterns, notice changes in behavior over time. Terminology, schemas, and vary across data sources. Integration data from disparate sources is a major challenge. Thank you.